this. Hi everyone, I'm Marina. I'm the corporate liaison for White Hat, do various things around here, and today I'm going to be talking to you about UNIX and kind of an introduction to what that is, what it means, and kind of how it applies to all of you. So first of all, what is UNIX? How did it get started? Why do we talk about it? So in 1969, the Bell Labs, which was kind of the lab offshoot of AT&T, that did a bunch of computing things back in the 60s and 50s kind of era. They were working on a project called Multics, which stands for that Multiplexed Information and Computing System. And basically the project was deemed a failure, and so it was canceled. But they had a bunch of these engineers that were around who had previously been working on this project. So the project was basically, the idea of it was an operating system. I don't think they called it that yet, though. But they had all these people around who knew stuff about this, but now weren't working on it, and they were working on other things. So they found a PDP-7 that was kind of sitting around in the basement of Bell Labs, and they really wanted people to play space travel on it. And so this inspired them to start looking into how they could play this game on this computer. And so what came out of this was that they built UNIX, which was kind of their play on the previous name, which was basically an operating system that they could use to play space travel on this PDP-7, written entirely in assembly for video game pleasure. And then Bell Labs found out about this project and decided that it was a good idea and started sponsoring the project, and kind of it started iterating and getting versions released. And eventually it was renamed. The CS became an X because they thought it looked cooler. And the developers later created the language B because they were tired of writing assembly, and so they wanted to write something else. So they wrote a programming language called B, and then they later wrote C, which is because they had some design problems with B that they then fixed in C. So, so now we have C, which is programming language is really that the most modern versions of Unix are written in C. So that's kind of where that was created. And they released the code to the public in 1975. So this is a little bit weird. It was not open source, which is an interesting distinction. Bell Labs and AT&T owned the rights to the code. They released it because of various licensing reasons so that it could be released on hardware, but they were not releasing it to the public, which later became an issue when other people decided they wanted to try and use this code. They were sued, and it was a whole thing. So they released the code, but this was not the first open source operating system. This was just the first kind of Unix system. So then there's this other kind of branch that I'm going to talk about, and I'll kind of show how these fit together in a minute. But Linux, which I'm sure some of you have heard of. And so what this is so Richard Stallman really wanted to create a truly open source operating system. He wanted it to be free to the public, free for anyone to use. And so he started working on the project. And he was developing modules for it, and there was other people who were also interested in this idea of a free operating system. And so they developed modules for this operating system, and they had pieces of it. But what it was missing was a kernel. And I'll kind of explain what a kernel is on the next slide, but for now, let's just call it the heart of the operating system, some important piece that it needed to be a functional operating system. So meanwhile, there's this guy, Linus Torvalds, who was taking a class from the maker of Minix, which is just, for the purpose of this conversation, was another Unix-like system that was being developed by his professor at the University of Helsinki, or I think that's how you say that. And so, yeah, he was there, and then so he was kind of inspired by all this operating system stuff that was happening at the time, and decided that he was going to write a kernel for the GNU project. And so he made the free kernel and called it Linux, named it after himself. And then, so that was then added to GNU, making it a completely free operating system that was released, and we've kind of been iterating on ever since. Okay, so what was this thing that he actually made? The kernel. So the kernel, so the kernel does a bunch of really cool stuff. So the operating system is kind of the thing that first comes on your computer. It's the stuff that runs all the applications, it runs all the programs, it runs everything that happens. And the kernel is kind of a subset of the operating system that does the core functionality. It's not really a computer without that. So it talks to the hardware. So if you type into the keyboard, that goes first to the kernel, and then if applications need it, then the kernel then passes it up through the layers to the applications. Same thing with if you plug a USB in, it usually goes through the kernel or any other type of hardware applications. Your CPU and memory are also, because those are also hardware items, they're also stored. They also go through the kernel for anyone to access them. So it does a lot of really cool functionality things, but it also means it's the key security layer of the operating system, because it gives you all the access to memory and CPU and external devices and all the kind of stuff that you can do with those. So they're supposed to, and they usually do, include a lot of protections to make sure that only people with proper access can get access to those, and like you can't just, like someone randomly can't just log onto the computer and start like deleting somebody else's memory from the computer, because they wouldn't have permission to access that, and you wouldn't want anyone to be able to do that. That's kind of the general idea of a kernel. It's kind of the layer there. Does anyone have any questions about that before I move on? It's kind of the what that is, how it's important. Cool. So this whole Unix idea kind of kicked off, and this is the family tree. So we started up at the very top there. I know it's really hard to read. The exact names aren't important for right now. Was that Unix, that first Unix system that was created, and then a bunch of people saw that code and created companies and did all these kinds of things, building different operating systems, kind of based on that idea. And over here on the side, these are called Unix-like systems, because they didn't technically derive from Unix, but like Linux is included there because it was inspired by it, but it wasn't the same code, basically. And so you'll notice up there almost every operating system that people use, except for Windows, I think is as far as I know, the only one that's missing from up there. I might be wrong. So yeah, because it was derived, it was kind of like a separate family tree, the Windows one. So a different like philosophy behind the operating system. So yeah, and that. Okay. So why do we care? We have operating systems, right? So why do we care? So the reason we care is that a lot of people use Linux. And as hackers, we're really interested in knowing what we can do on these systems and how we can find vulnerabilities, patch those vulnerabilities, etc. And because Unix is used by so many different people, like I said, probably almost everyone who's not on Windows is on some sort of a Unix-like system. So learning skills that apply to Unix environments apply to a lot of different computers that you'll find, including a lot of servers have Unix systems. The Cal Poly specifically has Unix machines that I'm sure some of you have used before. Internet of Things is mostly run on Unix devices. I think mostly Linux, I believe, on IoT devices that you'll see in the world. So yeah, basically in conclusion, anything that's not running Windows is probably running some sort of a Unix-like derivative. So what's the security implications of this? Kind of like, let's bring it back to that. So again, like I said, Unix is kind of the backbone of the internet, and as such, most security problems with the internet have to do in some way or another with the Unix system, and how either they're networked together, or how they're running things, or how various other things are happening. And often operating system exploits happen. There's definitely also a category of those on Windows, but there are also a lot of Unix systems. There's a lot of exploits that happen and are patched and are talked about. And your operating system is also kind of the foundation of your trust in your model. Because when you're using your computer, like every time you touch the keyboard, it goes through the operating system. Every time you plug something in, it goes through the operating system. So it's really like the thing that you trust in your computer and the thing that you really hope that your applications are talking to correctly and it's not being spying on you or doing any other things. So it's kind of, it's the root of understanding what's happening on your computer. And also because CTFs, I've solved multiple CTF challenges just with Unix skills. Oftentimes they have to be paired with other things, but sometimes they're just Unix challenges disguised as other things. So it's a good thing to know about for that as well. Okay, so how do I use a Unix machine? So the first thing you want to do is you want to find a shell. So it's basically the thing that executes commands. There's a lot of really interesting stuff going in the back end, but as far as what it does is you open a window and you can start typing stuff and it does things. That's the general idea there. So what kind of a shell do you want to use? Because this is like your main tool. So I think it's one of the most important things to understand and be able to customize and know what you want to do with. So I created a handy list here. There's a bunch of different shells that exist. SH was the first one. It's not really used that much anymore. It's not even the default in very many systems, but it looks something like that. That one is bash. That's what is installed by default on most systems. So if you like on Mac OS and most Unix or Linuxes, I don't know how to say that, this is what's installed by default. And so if you just open up a terminal, this is usually what you have. There's also FISH, which stands for the Friendly Interactive Shell. Actually, does anyone know what bash stands for? I forgot to look that up.
Born again shell.
Born again shell. So anyway.
There used to be a born shell. Yeah, that's the born again shell.
Got it. So anyway, this one's the Friendly Interactive Shell. This is a really common one. It comes with a lot of default customizations, which are really nice and that a lot of people appreciate. I'll talk a bit more about customizations later, but basically it means that it has a lot of things that it does for you, like color schemes and prompts and other things. So it's a nice one if you don't want to do too much customization and just want one that does lots of stuff for you. There's also ZSH, which is nice because it's a superset of bash functionality. So if you know anything, if you have learned anything about bash scripting, that applies directly over to ZSH, which it does not quite to fish. You can run bash from fish. But ZSH in general requires a little bit more customization, so a little bit more time up front, but then as far as I can tell, there's most of the same features that exist, so it's kind of mostly a preference thing. Yeah, so these are kind of this is your tool. This is the thing that you're going to do the rest of this stuff on. Yeah. So the next thing you want to do now that you have a shell is you want to configure it. You want to make it yours, because if you're going to spend a lot of time using this tool, you want to make sure that you know what it's doing and you can like do things quicker and make a lot of convenient things. So the bashrc, .bashrc is if you want to bash or I think ZSH as well. No?
Yeah, it's ZSH-RC.
Okay, so anyway, most of them have some sort of an RC or configuration file or whatever. That one's for bash. Other ones, they're pretty easily Googleable. You can just find where the configuration file is on your system. And in there, you can include a lot of different customizations. Most importantly, you can change your font colors. Oftentimes, shells come with a default black and white font scheme, which I think some people like, but it's not really my thing. I really like pink fonts, as you might have be able to tell from my slides. So it's usually the first thing I do on a new machine is figure out how to make the terminal more pink. But other people have different things that they really prefer, and the point is that you can customize it, and if there's something you care about, there's usually a way to make it happen. These other things are usually a little bit more about your editor, but they're also things that are useful, and like if you're looking at things, they help you kind of parse through it faster. Like some things like if you like line numbers, or if you don't like line numbers, or whatever, if you want to be able to see directory info, when you type stuff into the shell, you want to know what directory you're currently in, or other information. Like if it's a Git repository, maybe it'll tell you that, or whatever. And then there's the whole tab stop, tabs and spaces, how you want to organize your code, which is always interesting. Yeah. So this is another really cool thing that I think, especially as Cal Poly students, you all might find interesting. So how many of you have used SSH to access something? Okay, awesome. So this is a nice little thing to make that easier. If there's a server that you SSH into all the time, for example, this is the school one, so the Unix machines at Cal Poly, and you don't want to have to type unix1.csc.calpoly.edu and your username and everything every single time you want to log in, this is a nice shortcut to get around that. This is exactly what mine is for the servers here. And one thing I did, which is not super clear from there, is what you can also do is you can create a public-private key pair on your local machine, and then put the public key onto the servers in what's known as the known hosts folder inside your .ssh folder. And then you don't even have to type your password. So you literally just type ssh unix1, and it'll just go in. It'll have done the key exchange for you, and you'll just be in the server without any extra typing, which I find super useful. You can be done for other servers as well. So any server that you're accessing all the time, this is a quick way to do that without all the typing, which is always nice.
This also works for SCP.
Yeah, it does also work for SCP, especially the public-private key pair thing does it. Yeah.
And the other thing is it's a little harder to find, but you can't set up to bounce off another computer.
Oh, yeah.
You want to log into like the parallel computers. Some of the classes require certain hardware that you want to log into. You can set it up so that it will just go directly. It'll actually go off a server to that computer, but it looks like it's going directly to that computer.
Yeah, I took that out of the config file for that, but yeah, it's cool. You can do all kinds of stuff with that. If there's ever a server that you're accessing all the time, you can make it as easy as possible to access it, basically, which is really cool. So what else do you can do with this new shell that you have running? So installing new tools. Because usually, you'll find some really cool tool on the internet, you're like, so how do I use this? How do I get started? So I have kind of a general introduction. The real answer is that it's different for every operating system and every distribution and all those different things. I do have specifically any Debian variant, including Ubuntu. You usually used what's called apt to install various software. So you use apt install software name, and if it's included in the package manager, it'll just install it for you. And you don't have to do running any of the scripts or anything like that. It just does it all for you. On Mac OS, there's a similar tool. It's called Homebrew. You have to install that one, and then from there you just type into the terminal like brew install program, and then it'll install it for you. So it's really convenient, especially if you find yourself installing things all the time. This will save you some time, do a lot of the work for you. So now that you have these cool new tools, you want to learn how to use them. So that's where man pages come in. Most command line or terminal tools come with a man page, which is basically just like a really in-depth description of everything that they do. Usually it's written by the developers of the tool. So it includes like all the options that you can add to it, all the parameters, just kind of anything that you need to know in order to be able to use it. Sometimes you can just read through these and find cool new features that you didn't realize, even in something like ls. It can do all kinds of cool things. Yeah, so these are super useful, and I highly recommend like the first place to look. Occasionally they're a little bit unreadable, and there's one or two tools that I do still end up going to Google for, but this is usually a nice first place to start. So part 2 of the talk is just cool commands. So before we go on to that, does anyone have any questions about kind of the what a Unix system is, how to set it up, that kind of half of the talk before we move on? Yes?
Which shell do you use?
I use fish. Except I changed the color scheme. Yeah, so I really like the arrow to complete commands. Like if you type a command all the time, it'll remember it, and you can just like push the arrow, and it's like completes it for you, which is really nice. I'm sure there's something similar in ZSH. I just don't know it because I don't use it. So, yeah. Anything else? Awesome. This is part 2 where I just like have a list of some really cool commands that I really like and found useful, and got some ideas from some friends and stuff. Hopefully some of you find them useful as well. So the first one is tmux, which stands for terminal multiplexer, which is a really confusing way to say that you can control multiple terminals from the same screen. So basically, if you're in your one screen and you want to be able to control like 2 different screens at once, you can use tmux to kind of attach and detach from these different screens and access them. The main reason I use this is if you're on a server. So you're SSH'd into the server, so you're not actually on it, which means as soon as you un-SSH, as soon as you like control the other process, anything that you're running is no longer running. Which, if you want to run like a really large project or something that takes like more than 5 minutes to run, you kind of want to be able to run it and then go get some coffee, come back, see if it completed or whatever. So what tmux allows you to do is you can start the process running in a tmux window, and then tmux detach. So it's still running on the server, but you don't have to stay SSH'd in to make sure that connection stays going. And you can just go away, do whatever you want, come back, SSH back in, reattach to that process, and it'll either still be running or show you the output or whatever it's doing on there, which is really nice. Especially because sometimes SSH connections aren't super stable. So if you have an internet connection that's not very great, you want to make sure that your process is still running, is still doing the stuff that you want it to do. This is a great way to make sure that happens. Another good use is if you can use it locally as well. If you just want to use a bunch of tasks and you want to just have like your one terminal that you're doing all those things on. It also provides nice functionality for like alternating between windows without using the mouse, which some people are really fans of. So super nice for that. The next one I have is find. So this is basically a really cool way to just find files. Basically what it says, it'll look for the file in subdirectories, and so I have some examples up here. So this first one will find a file named exactly file.txt. What's nice about find is that it looks recursively through directories. So if it's in the folder that you're currently in, it'll say, okay, yeah, here's the file. This is where it is. Found it. But if you have like some ridiculous folder system that you don't really remember how you organized it because it was like 6 months ago, and you know that you named the file this, but you don't know where it is, you can run find and that file name, and then it'll print out the path name to it. And you can be like, oh yeah, for some reason I put it in this miscellaneous folder that I created, or whatever. You can also do it to find any like C files that you have or any other type of file that you need to look for. It can just find all of those, print them out for you, so you can have access to them. And if you can't even remember the name, you can, if you remember like when you last looked at it, or the size, or the owner, or anything like that, you can search for any of those things, which is super nice. And these are a couple of basic ones. These ones require a few more options, which are all available in the man page. So the next one is Xargs. So this one is super useful. This is probably the one I've used most in CTFs. It's really nice for chaining arguments together. In its most basic form, it just executes a command. So the first thing you think is like, so why don't I just run the command in a terminal? So as you can see, the main use of it is running another command and then piping it to this command. So what the pipe means basically is that you execute this thing, and instead of just printing the output right here to standard out, you group it all together and you pass it to the next argument. So like for the second example, So find dash name bash. So you're finding anything with the word bash in it. And then you're collecting that list. And then you're passing that on to Xargs. And what Xargs does is it prints, by default, prints things slightly differently than your terminal does. So your terminal would print all of those each on a different line, whereas Xargs by default space separates them, which is sometimes nice if you have like a ton of files and not a very large screen. You can see them all at once. And this first one, it'll find anything that's a Java file that ends with .java, and then it'll look inside of those files using something called grep, which I'll explain a little bit more about in a second, to find any use of the word stock inside of that file. So basically what it does is it prints out any Java files that have the word stock in them. So if you have like some class called stock that you don't remember where you declared it, this is a nice way to find everywhere that it's used and declared, or something like that. And then sift. So this is actually what I use instead of grep. Grep is what was used on this past file, this past slide, I mean. Yes?
So what you're saying is Xargs runs the command on the right on all of the things that output from the command on the left?
Yes. Yes.
You can also do those backticks in bash. You backtick in a command, it'll run the command there.
Oh, yeah. Yeah, so I think that some of the Xargs functionality can be used with backticks as well. I find this a little more readable, but I think that also works. Cool. So sift is a cool way to find things inside of a file. So find finds it by the file name and the file info, whereas sift finds it by what's in the file, the contents of the file. Yeah, so basically, if you know that you have like a really big coding project, and somewhere in this project you declared something called find, and you're like, okay, I don't know where to declare this variable find, but I know I have it somewhere. So you can run something like sift on your whole directory with the code, and you can find all the instances of where you used that variable, where you declared it, and everything like that. So the most simple example is just like sift word, and it'll just like look through all the files, find the instances of the word, and print them out. Print out the files, and then you can go in and like find it and everything. You can also chain it with other commands, do complicated things. One of the nice things about this is oftentimes people use grep, which does a lot of the same functionality, but grep tends to be really slow because of the way it searches through files, and it's also not recursive by default. So if you're not careful, it'll just search the current directory without going into any subdirectories, which is usually not what you want. Sometimes it is. I think this one has an option for non-recursive as well. But sift is usually faster, and it sometimes finds better results, or by default has better behavior. So yeah, those are some cool commands. I'm sure other people have others. This is just my short list that I had for this.
There's another grep alternative called ag if you're on OSes.
Yeah. So yeah, this is just some resources, some other things. Bandit is specifically CTF-related Unix things. So it's war games about Unix commands. It kind of helps walk you through a lot of the basic commands and how to use them. It has you look up man pages to do different options and stuff, which is a really great way to learn lots of cool commands. I learned probably most of the basic commands I know from going through those challenges. This next one is a couple of links I found online. I read through them, but I'm not going to completely say I condone them because I didn't memorize them. But they have lists of the basic commands and probably the most commonly used ones, things that you should know in order to be able to use a terminal, that kind of thing. The next one is man pages. So if there's ever a command you want to use and you don't know quite how to use it, quite what the arguments are, or something like that, you can look up the man page for it. And if you don't quite know what the command is that you want to do, feel free to either ask one of us or Google it. There's lots of cool resources online. Stack Overflow usually has multiple solutions to any problem posted about Unix commands. Professors' office hours, the professors here are really great at using Unix. Most of them use it all the time, so they know lots of things about it. So a lot of them know, most of them know more than we do, so great people to talk to. If they're too intimidating, you can also come talk to white hat officers. We also know a few things sometimes. and are happy to help out people learning about things. So yeah, that's my talk. Any questions, concerns?
I like something about JS.
Yeah, no less.
Yeah, what's up?
So which distro should we use?
I'm the wrong person. I use macOS. I'm really the wrong person to ask. I think a good one to start with, I would say, is either probably Mint or Ubuntu. They require a little bit less setup than some of the others. If you want to spend a lot of time setting up, there's lots of other options as well. I'm sure, yeah. I think Nick has set up most of them at some point in time. So.
All during computers. Yeah. And there's also the Linux users, the couple of Linux users.
Oh, yeah.
Around. They're somewhat active. They're more active than they have been in the past.
Yeah, so they're another good resource.
They had a talk on distros recently.
Yeah.
With donuts.
So they have other cool resources about this kind of thing. Anything else? Just random questions about this kind of thing. I'm here. What's up?
Why do you use fish instead of like bash?
So I used bash for a long time, and then someone finally convinced me to try something new, which is I think the hardest step of switching over was just convincing me that I could break the muscle memory. But I really like fish because mostly the completion. That's what sold me on it. Is that in bash you can do tab completion, but if there's like two things with the same name, like say I have two folders that start with S. One of them is school, and one of them is like. So I think it starts with S, like soda or something. And I never actually entered the soda directory because I created it 10 years ago, don't know what's in it. But I always enter the school directory. Bash would every single time give you both of those directories, whereas fish will just suggest the school directory, which is a really nice feature. Yeah. It's kind of hard to explain without demoing, but it's pretty cool.
To that point, I used bash for 2 years, and like was always just like, no, I don't want to switch. It'll be like
Yeah.
too much effort to figure out how to switch. And then like I finally switched over, and it was just so worth it. So don't like put yourself through bash because bash is very user friendly.
And you can always switch back. Like it's not a big deal. Like if you end up hating it, it's pretty easy to switch back. It's actually way easier to switch back than it is to switch. So, yeah.
I think learning bash is sort of important though, especially since like the school servers don't include.
Yeah, I think learning how to use bash, because like most of the things you do are the same on any system, on bash or on fish. Like typing commands like cdls, all these commands are mostly the same. The only thing that would be different is bash scripts, which if you know those are cool, if you don't, it's not a big deal. But like they're basically just things you can do, but they're written in the language bash, which also runs on GSH, but it does not run in fish. Fish has its own language, but it's not as popular. Usually what I end up doing is just calling bash file from fish, which runs the bash file as if you're in bash, which is cool.
Or just run shell.
What?
Just run sh.
Yeah, you just do that.
If you're on Linux, you get to shell.
Oh, yeah.
Or actually, it's ash, right? Yeah.
If you ever take operating systems, you get to learn what an operating system is like before they added all these really cool features that you use. Yeah.
And then if you take OS2, you get to make all those cool features.
Yeah.
Finish the project.
However, when's the next time they're going to offer OS2?
That's actually another good resource that I forgot to mention is just the classes that you take. Operating system goes a little bit more into depth about kind of Unix and Linux and kind of like more about like the kernel and how that is made. And then in some of your other classes, you'll end up using things like SSH and other things. So you can always feel free to ask your professors or TAs how the things you're using work and kind of extend that as well. So, yeah.
I would say the biggest thing is like configurations. Like it's like you can configuring your shells makes it a lot nicer.
Yeah.
You get color highlighting, and you can add your own custom like little commands. Like you get tired of like making a directory and moving into a directory. You can make a shortcut for that.
What I find is that basically anything that I find annoying in it somebody has solved with a configuration. So you just have to like figure out what that is or find someone who's fixed it or whatever. There's something out there.
Why do you have to type sudo before some commands?
So basically, it's a little bit beyond the scope of the talk, but basically what it does is it runs things as the kernel. So it has to do with like the privilege difference between the kernel and the root process. The root process is basically the process that's like in charge. It's like it's assumed that it's like the what's it called, the admin and the manager of the system, and so they have a little bit more permission than just like a user does. And usually, even if you're the admin or manager, you don't want to run everything as the admin in case you like delete a file that you didn't mean to or do something like that. You want to make sure that something stops you. That's kind of what the root system does. So when you run sudo, what you're doing is you're running something as root. So you're running it with more permissions. You can do a few more things.
You can also break a few more things.
Yeah, you can also break more things. So just be careful with that one. What's up?
So is super user the same thing as sudo?
I think so. Yeah.
Sudo stands for super user do.
Oh.
Yeah. So yeah, the root user is the super user. When you're running sudo, you're like running something as that user, but you're not quite that user. You're just kind of pretending to be them for a bit, type in a password.
The super user account is usually named root.
Yeah.
Like it's the root account.
That's it. Yeah, so I think a couple good things to do is that the bandit challenges that I mentioned on the right here for reference are a super great way to get started, especially the first like 4 or 5 levels teach you some of the like the really basic commands and kind of the most useful ones. They ramp up a little bit quickly, but I think the first set of them especially are a really great way to learn some commands, and they kind of tell you which ones to look up, which is really nice. Another cool thing is just to like try using it. So like try navigating through folders, opening things, see what kind of gets stuck, see what makes sense. Yeah.
Another good way is if there's some like tedious task you do
Oh yeah, that's the
on
other
your
thing.
computer, see if you can write a script that does it and use the script to do it. Because you'll if you have a goal, it helps you like figure out all the necessary things to make that happen.
Yeah.
And then you have a cool little thing that does stuff.
Just describe my 4 years here at Cal.
I'd also recommend against going for the, well, I just need to get it done, so I'm going to install a GUI tool. Because I always find that screws me over. I'm like, oh, I just need to get this done, I'm going to install a GUI tool. And then I just end up using the GUI tool rather than actually learning like the commands.
Yeah, it kind of depends on what you're doing as well, but oftentimes you can get more customization on almost anything by doing it through a terminal. So for some things you don't need all the customization, but it oftentimes can help you do things faster or easier. So, yeah. Anything else? Cool things? You're gonna have any other cool commands that I missed that they think are the most useful thing? Oh yeah, strings. If you're doing a CTF, strings.
So I've done, just because sometimes I'm like, wow, my hard drive's really full of just crap, and I don't know where it is.
Yeah.
DU and DS, or DU and DF, short for disk usage and disk free. No, it's DU and DF.
You could probably Google those before just typing them.
Don't command that thing, but they'll tell you how much data is being used in particular directories and folders. And I've used that to kind of track down, like, all right, which folder, like I know like my home directory's got a bunch of data in it, but I don't know where.
Yeah.
I can track it down, like, oh, I've got like 4 old versions of iOS installed from that app I worked on a while back.
Yeah.
Those are like a gigabyte apiece. So that can be kind of nice sometimes to like track down where stuff went.
Also, this doesn't come standard, so you actually have to install it. But tree is really useful when you're like, I don't remember what's in that directory, especially when you start getting into like multiple subdirectories for each directory, because it will just give you a very nice printout of the entire subdirectory tree, so you can see what's going on.
I think my favorite command that I've ever seen, and if none of what I say makes sense, don't worry, because this command is useless. But it's if you have a Git directory, like a project that is being tracked with Git, then you can install and run Gorse, G-O-U-R-C-E, in that directory, and it'll play this little animation of like your face flying around and making little changes to like a big graph of all the code. And so it'll represent the files in little circles, and then like and then if your friends are also have commits working on the project, then their faces will fly around. And it's really ridiculous and useless, but awesome.
Somewhat similar to that, SL.
Yeah. So yeah, ls is one of the most common commands that you'll type if you ever end up using a terminal. So a lot of people like just type it really quickly and they end up typing it backwards as SL, which doesn't really do anything by default. So what people have done is they've created, and some people have installed, this program called SL, which just, if you ever type SL instead of LS, just freezes your terminal until a steam locomotive can like drive across it in little characters. Then you can go back to doing whatever you were doing. It's a nice way to break the habit of typing the command wrong.
People leave their computer open, like some security, just brew install SL.
Yeah.
Do not recommend that.
Yeah.
Don't do that.
Yeah, so.
Something actually useful you mentioned.
Yeah.
You mentioned copying over keys to log in through SSH.
Oh, yeah.
There's a command that's ssh-copy-id that will do that all for you, and then you can just
Oh, cool.
SSH
I didn't know that one.
password on it.
That's awesome. That one.
And Control L clears your terminal, and so you don't write clear all the time.
Or Command K on a Mac.
Oh,
Another cool one.
I do Control L.
Oh, I just
Oh, really? That was.
And do that because I used to type clear, and I'd spell wrong all the time, so I have about
20 aliases for clear.
Collier.
Yeah, Collier. Like every time I misspell it, I'm like, oh, just gonna add it to the list.
that happens a lot with people that get used to the terminal.
Yeah.
Is that you have like 6 aliases just for things that you always spell wrong.
Yeah.
There's also C-matrix.
Was that one?
That's useless.
It's great.
There's also like there's some really useful tools and some really useless tools. You can kind of pick a nice subset that you like.
Command that plays the entire Star Wars A New Hope in ASCII.
That's just a telnet command.
So if your friends leave their screen unlocked, don't be mean. Don't be mean. Don't delete all their files. Don't like eat their homework. But the cat command is very useful. It concatenates a file, meaning that it prints out the file to the screen. I end up, in an average day, I might use it a few dozen times. It's a pretty common command. It is acceptable to alias cat to echo meow. So the next time they cat a file, it just goes meow.
I've also seen it links that it would link to dog, and the error about dog not found, and you click that.
I am his roommate and his friend. I have been subject to both of those things. I don't leave my terminal open anymore.
Or you can just leave your friends' computers alone.
One thing I
You
like.
leave your friend's computer alone.
Kylan and then.
One useful thing you can do if you're using Unix a lot, you'll probably end up using Vim a lot, and if you use Vim a lot, you'll probably end up using escape a lot. So if you math caps lock to escape, your pinky finger will thank you.